Hey, and welcome back to the show. I'm your host, Zoe, and today we're der we are think and fime a finkas using someone else's, not just using someone else's, not just chatting with ChatGPT or Claude or Gemini, but actually building your own personal AI assistant, not just using someone else, not just chatting with ChatGPT or Claude or John, whether actually building your own hide stuff. I get so here is what we are going to cover today. First, I want to talk about why 2018 Treni ePincer's ecosystem is on fire. Then I'm going to walk you through the different approaches you can take from no-code setups that take 10 minutes to full-on self-hosted agent stacks that run on your own machine. We will talk about memory to the different approaches you can take from no-code setups that take 10 minutes to full-on self-hosted agent stacks that run a stacks that when it's run at 8 will take your will. Finally, I will give you my honest take on where to start depending on your skill level and what you actually want to achieve. All right, let us get into it. So first, why now? I've been watching this space for years, and 2026 really feels different. The big shift is that we have moved from chatbots to agents, and I want to be clear about what that means because the difference is not just marketing. A chatbot answers, an agent has their pursuance, an agent has its, and heeds. It can plan a multi-step task, execute it, observe the results, and adjust its approach if something goes wrong. And in some cases, it can even run autonomously in the background while you sleep. That is a fundamentally different thing, and the reason it is possible now is that three pieces finally came together. First, the models themselves got good enough at reasoning and tool use. Modern language models like Claude, GPT, Gemini, and open models like Claude and Quode and Teeperteek. Instead of writing custom code for every tool integration, you just connect an MCP server and your assistant can use it for aeroplane Forwest accessible. Let me give you a concrete example of what I mean. There is a project called OpenJarvis that came out of Centerit. It is a framework for building local first personal AI agents. The idea is that your assistant should run on your own device by default and only call the Claude Jarvis that came out of Stanford. It is a framework for building local first personal AI agent, Zakidance. And the hardware is ready. What was missing was the stack to tie it all together. Detever Ever is NanoBot. It is an open source personal AI agent that has almost 46,000 stars on GitHub. And the philosophy behind it is beautiful. Keep the agent core small and readable, but give it all the practical pieces. For real long-running work. A web interface. Chat channels like Telegram and Discord. Tools. Memium. Support. You can run it with OpenAI, Anthropic, Google, or local models through Alama. It has voice, browser automation, IoT device control, and even Telegram and WhatsApp connectivity. And it is all MIT licensed. So the question is not whether you can build your own AI assistant in 2026. The question is which approach is right for you. Let me break it down into three main paths. The first path is the no-code approach. And yes, that is absolutely a thing. If you did not put you create a new project, you write a system prompt that defines exactly what your assistant should do, you add your personal context, maybe upload some documents about yourself or your work, and you set up rules and constraints. Within 10 minutes, you have an assistant that knows you, that remembers your preferences across conversations, and that can use tools like web search and document analysis. Is it fully autonomous? No. But is it incredibly useful for daily tasks like planning, writis, or you connect an LLM node to a tool node to a memory node to a web search node, and suddenly you have an agent. The agent leads to real business systems because it has over 400 native integrations with things like Google Workspace, Slack, Notion, and databases. Flowise is better if you need fine-grained control over the agent reasoning chain and ROD pipelines. And the best part is, you can run both of them on your own hardware using DACWIT. The go-to frameworks here are LangChain and LangGraph for Python, or the Versal AI SDK for JavaScript. That gives you portals with branching, retries, and human-in-the-loop approval steps. It gives you a graph-based architecture where you define exactly how your agent thinks, which tools it can use when it should ask for help, and how it recovers from errors. And if you want multi-agent systems, Crew AI is the framework the Lees. The weight you both sear. Real multi What matters more is how you handle memory. Memory is the difference between an assistant that feels like a tool and an assistant that feels like a partner. There are two kinds of memory you need to think about. Short-term memory is the current conversation. What did the user just say? What was the last tool result? What is the current state of the task? This is usually managed as a sliding window or rolling summary within the context of the LLM call. Long-term memory is everything that needs to persist across sessions. You take each piece of information, convert it into an embedded, which is basically a numerical representation of its meaning. It searches the database for semantically similar content and retrieves the most relevant memories. This is called RAG, Retrieval Augmented Generation. It is the standard approach and it works incredibly well. There is a project called Lethe, Retrieve Augmented Generation. It is the standard approach, and it works incredibly well. There is continuous memory across tides. It runs on your machine as a container, persists across reboots and model upgrades, and it is a single 50 megabyte static binary. That is the kind of thing that was science fiction 2 years ago. Another project called Chaley takes a different but equally interesting approach. It runs on your own machine as a reasoning engine that keeps working while you step away. It has self-managing memory where episodes become concepts, become abstractions, weighted by source, by Stiquagel, and then there is EVA, which is a persistent local AI with memory, reflection, and autonomous outreach. The developer behind it documented the journey of building an assistant that can listen, speak, remember, reflect, form new thoughts from stored memories, and occasionally reach out to the user on its own. At 360 stored memories, the system was still functioning correctly, with coherent retrieval and natural feeling interactions. Semantic retrieval across a growing body of stored information, with data quantitative Step 1. Decide what your assistant will actually do. This is the most important step and the one most people skip. Do you want a writing cogen or a daily briefing agent? Pick one job, build for that. You can always expand later. An assistant that does one thing well is infinitely more useful than an assistant that does 10 things poorly. Step 2. Choose your model and infrastructure. If you have a decent GPU, run a local model through Alma, Cupid at 14 billion The key is to pick a model that is good at function calling and instruction following because that is what made its work. I affirm. That's what fastest path to a working prototype. Use N8N with its AI agent node. Connect an LLM, add a tool node for web search or your knowledge base, add a memory node for memory. Tech my LLM, add a tool node for web search or your knowledge base, add a memory node for cache and persistence. And you have a working agent in the afternoon. If you would not content to 12 DA, it's face retired, it didn't collect the outs. An agent with 4 well-designed tools outperforms one with 20 vague tools, because every extra tool is another chance for the model to pick the wrong one for long-term memory. Set up Qdrant or ChromaDB as a vector store. The trick is to be deliberate about what goes into context. Do not dump everything into the context window or RomaDB as a vector store. The trick is to be deliberate about what goes into context. Do not dump everything into growth quick as quick to work with the for paid. This is a step almost everyone skips, and it is the one that separates a toy from a production system. Create a set of real taps, ears, or real-time IWT and run them automatically every time you make a change. 20 representative tasks pulled from real usage beats 1,000 synthetic ones. Include the ugly cases, the ambiguous requests, the malformed inputs. Score what you can automatically and spot check trust. Step 7. Deploy with guardrails. Log every input. Every skill and have a kid and have a litmus, but even data decimator. And to date is never truly done. It is a system you operate, not a feature you finish. Watch the logs, feed the failures back into your eval set. Tighten the prompts and guardrails as real behavior teaches you. Where the edges are. Waff Point Duck about one of the most exciting developments in this space, and that is the concept of a personal AI operating system. This is as take to check your repos, your notes. This is the durable source of truth. Above that, you have a memory layer. This is a structured store that the AI reads from and writes to across sessions. It remembers facts, decisions, and context. Above that, you have skills and agents. These are repeatable, defined jobs that you invoke by name instead of describing every time. Your weekly review format, the way you turn a rough outline into a first draft, your research workflow. It's a skill at ounce. And it's expertise task per a skill wired to your memory layer produces output shaped by your decisions. Your facts is a mile. Executains on mile 1 is an operating system doing your work the way you would. And the standard way to connect these layers in 2026 is MCP, the Model Context Protocol. It is the connection that lets an AI client reach external tools and data sources. A memory server is an MCP server whose job it's kubolden batais. Yidvai Coddles for It is like a desktop AI app but open source with a work brain that uses background agents to index your emails, meeting, and notice into a living knowledge graph that updates itself as you work. And instead of just a chat interface, it gives you work surfaces, an email client, a meeting note taker, a browser, a code mode where you and the AI actually collaborate. You can bring your existing Obsidian Vault, connect Slack and other services, and let it run your day. That is the direction the it builds a private context graph, a structured knowledge base about how you work, what you prefer, and the patterns that define your professional workflows. It is inferred from behavior, not from explicit statements. It is continuously refined. Every task updates the graph with new observations, and the most important property is that it compounds. Each task makes the assistant slightly more personalized, and because personalization improves subsequent task quality, the value curve accelerates over time. Write a good system prompt, add your context, set up rules, and sepanavrias and you welds. Learning to spend a wayland on hardware, and you're willing to spend a weekend on it. Set up Alama plus N8N plus N plus Team Drat. Alama gives you local LLM inference. N8N gives you workflow orchestration. Agent Triggans. Trigrant Krent gives you vector memory. Adrighty. But they're all MIT licensed, actively maintained, and they give you a complete system out of the box. If you want something truly local and private autonomy, local first, with a structured knowledge graph and no telemetry. Homie is a self-evolving local AI sovereignty, local first, with a structured knowledge graph and no telemetry. Homie is a self-evolving local AI assistant that detects your hardware, downloads a model, and starts working with no accounts. And Ibico is an open source spare to take care of its the tooling in 2026 is mature enough that a competent developer can build a genuinely useful agent in a weekend. The hardest part is no longer the technology. It is deciding what the agent should do, proving that it does it reliably, and keeping it honest once real users show up. Let me wrap this up with a few final thoughts. First, the most important lesson from everything I have learned about this space is that you should start narrow. Build the smallest agent that solves a real problem. Prove it yes, quaffed. It's that was that in 100 under Fintapossum. Dawins that a need. If living favs, you do not need to be a machine learning engineer to build a personal assistant. You do not need to train models from scratch. What you need is fluency in a handful of areas. Writing clear prompts and instructions, designing and describing tools, building retrieval to surfaces the right context, and reasoning about evaluation. A working knowledge of how large legs miles, betwales, it sing of smandouts. Ready at spells, but we got agents that can self-evolve and read their own source code. We got personal AI operating systems as with Tubstars, and the pace is not slowing down, it is accelerating. So here is my challenge to you. Spend an afternoon this week building something, not buying something, not subscribing to something, building something. Start with a system prompt, give it a job, use it for a tiles, it ease it for a tile heel, Given memorials to Gabalt year comics and you just have to reach out and grab it. Thank you so much for listening to this episode. If you enjoyed it, please share it with someone who might find it useful. Subscribe wherever you get your podcasts, and I will be back next time with more stories from the edge of what is possible. Until then, stay curious, keep building, and I will talk to you soon.